Good afternoon, and thank you for attending today's meetup session for Ansible for Networking. Today, we're going to talk about AWS Networking, and this is actually the second of a multi part series where we're going to explore different aspects of automating AWS networking using Ansible. So, for those of you who I haven't met before, I'm Tony Dubiel, and I have a background as a traditional network engineer. I've built and deployed and worked in different roles, primarily around um, you know Cisco, Juniper, Arista, the mainstream networking providers, just building and deploying network infrastructures. And while I was at Cisco, I converted over into more of a net DevOps type of net developer. And from that, I really enjoyed Ansible and came over to Red Hat, and that's where I am now. And I'm out of Raleigh, North Carolina, and primarily, again, my specialty is now network automation. So before we get too deep into today's topic, I wanted to do a recap, primarily for those who may have missed the previous session. And that was a more 101 level, I would say, just a nice introduction to some of the basics of AWS networking. And then that culminated in a demo using the Ansible automation platform with a job template to build what you see on the screen here. So before we get into today's topic, I just want to kind of unpack this a little bit, and we'll just recap here for a second. But let me go back to this screen here so I can see everybody. So one thing, when I'm in other screens, I don't always notice what's going on in the chat room or in the Q&A. So if you have a question, feel free to just unmute yourself, and then that way you can grab my attention. And I'm happy to stop at any point, to clarify any of the things that we're talking about on the AWS side or on the Ansible side. So one thing before I go back to the slide deck is, if you attended the previous session, could you give me a thumbs up just so I have an idea of who saw that and who's seeing this for the first time? Okay. Okay, good. So it looks like most of you that are on the call right now did see that. So I won't spend too much time here, but just some, real quick recap. So one of the things that we talked about last time is everything that we were building was a VPC. And some of the things that we noted were that VPCs are bound to a region. So we created a VPC in a region, and in that VPC, we created two subnets, and each subnet was in its own respective availability zone. And moreover, what we did was we included a load balancer, an application load balancer, so that way we could load balance between two web servers. And then in order to have the ingress and egress internet connectivity, we had an internet gateway. And this is just the logo for a route table. This isn't the actual routes that we were using, but we needed to populate our route table, which was a very basic route table because all we really needed was a default gateway, to be able to, exit our VPC and have internet connectivity. So that's all we did, and it kind of touched on most of the topics that typically you would need to understand first, right? Because as you're building a VPC, it's pretty straightforward. You can use the portal, cloud formations, Terraform, a lot of different tools you could have used, and certainly Ansible can, easily build what we did last time. So now what we're doing is we're kind of taking a step forward. And if you're interested in any of the playbooks that I used the last time, as well as the ones that we're going to use today, then this link here will provide you that repo. And after these sessions, if you didn't already notice, I go ahead and I'll save this slide deck, and I'll provide like a Google Drive link on the meetup site. So if you go back to like a past event, you'll see the links to the previous slides and anything else that's pertinent that we used during that session, you can always go back and I'll have links there for that. So there's no need really to do screen captures or anything like that, unless you want to. But you can always go back and just get those slide decks, as well as recordings too. I'll put those out on YouTube. So today, what we're kind of doing is, we want to be able to connect multiple regions together in separate VPCs. So it's kind of like from the perspective of like 101. VPC peers like within a region is pretty straightforward and easy. So I figured we'll just go ahead and skip that particular scenario and go into VPC peers across regions. So when we do that, it gives us the ability to have this one-to-one relationship with everything that we're connecting to. So this could be in region, but today we're going to have two of these, but they're in separate regions. Will be in U.S. East and also U.S. West B. So it's like the Ohio side on the east and Oregon on the west coast. So those in particular, and when we go across regions, there's a couple of limitations, like additional limitations that we have to take in consideration. But for the most part, whether it's in a region or it's out of region, it's basically doing the same thing. So it's giving you these one-to-one relationships. So these relationships is like, requesting connectivity, accepting it, across these VPCs. And also, what we'll talk about is we need to pair that up with a route table and security groups for our endpoints. So ultimately, these end devices can talk to each other between these VPCs. And one other thing to note too, that I think I have it over here in the bullets as we go through these, is that we can't have like transit routing. So like in this particular diagram, if you don't consider that or make considerations for the transit routing, you can see that it could be kind of misleading. Where if you think that B can talk to C through A, right, and just as a transit route, that doesn't work. So that's really the next logical step after this. If we wanted to accomplish that as our end goal, then we would move to transit gateways. So here, all we can do is create like a mesh between the things that we want to talk to. So having said that, and considering that B can't talk to C directly through A, then we could connect B to C if we wanted to. But the challenge there is this solution, VPC peers, is fairly straightforward, although we do have to address the route tables, so that gets a little bit complicated. But we have some limitations. So if we need to have more than 50 active peering connections, so if we have like a large mesh between many sites, then we have to account for that. And also, we have to worry about our overlapping address space. So as we create CIDR blocks in these regions for these VPCs, we have to plan our IP addressing such that we're not overlapping as we connect these VPCs together. So that's kind of the second thing that we have to worry about. And like I mentioned, the VPC peering does not support the transitive peering relationships, right? So, I'm sorry, this one is, yeah, that's what we're talking about. And then this should be a bullet here, so I have to fix this slide. The maximum transmission unit, MTU, when you're peering across regions is only 1,500 bytes. So yeah, this whole bullet got messed up. I'll have to fix this slide. But so that's important too, depending on what our use case is. So if we're just connecting servers together and it's like application traffic, then that's not a big deal. But if we're like have our own databases outside of like the database services that AWS offers, and we're doing replication and those types of things, then normally we would want jumbo frames, just like we would in normal data center network fabric communications, right? So we would want more like a 9,000 MTU versus 1,500. So those are the main limitations. There are others, as the devil's in the details, depending on what you're doing in here. But these are like the main ones that you have to kind of think of up front to determine, should I even bother with VPC peers for this particular use case, or do I really need to, move forward with the, transit gateways? I think another thing that I wanted to put on here that I forgot was this last bullet, and that was also alluding to the type of routing. So these are static routes. that I'm talking about when I mention a route table. When we get into the transit gateways, we can have, they're kind of like route reflectors for BGP that we can enable. So it's a lot easier in that regard to manage more sites because you're using dynamic routing as opposed to a bunch of static routes. But in a smaller environment, in a handful of these things probably is where you would start to move forward or move away from this particular option. It does work okay, and with automation, it makes it a lot easier, right? So we don't have as many touch points to go in and worry about touching every route table, every security group, and those types of things. We can simplify that and abstract a lot of it through automating it. So here's just an example of the type of route table. In the previous session, if you recall, the route table was really just a default gateway, right? So that was pretty straightforward. In this case, we're not just pointing to the internet gateway like we were the last time because that was our default route, out and in from the internet. This time we have the peer connections. So they have an ID when you create them. So we have to address those in our routing table because those are the connections that are going to be, across these VPC networks within, the AWS infrastructure. Then that's what we're routing is to, these peer connections that are created, when we initiate that request for the VPC peering. And we'll see that in our Ansible playbook because there's a module that handles this component and us also thus, updating our route tables. And then the last thing is just something that we have to take into consideration because our security groups are typically set up to work within our VPCs, right? And as we connect these VPCs together, now we have these new networks because I alluded to earlier, when we do this, we must avoid the overlapping networks, right? So these are networks that do not exist yet in our route tables, right? So we have to allow for these CIDRs and these subnets that we've created and want to allow connectivity between these VPCs. We have to add those to our route tables, but also we need to account for them in our security groups, right? So if the security group doesn't allow for whatever that address space is for a particular protocol to the endpoint, then even though we have the VPC peer working correctly and we have a route, we also need to allow for it in security groups, when we're using those. So moving forward, and let me just check here real quick to make sure there's nothing in the chat or anything, any questions. Okay, so it looks like we're good in that regard. Oh, and I forgot to turn my camera on here, so let me do that. So in this particular scenario, what we've done is we still have all the things that we did originally. So in US East B, we still have the two web servers, the load balancer, application load balancer, the internet gateway. All that should work. So when we spin this up, we're also adding to what we did on the Ansible side. If you recall in the demo portion, I used a job template. And a job template in the Ansible Automation Platform controller maps to a playbook. So it's a one-to-one relationship from job template to playbook. When we want to stitch together multiple job templates, then we can create a workflow. So a workflow can have multiple job templates, or in fact, a workflow can have multiple workflows. So some of those workflows can become very complex and have a lot of logic and conditionals as part of them. Ours will be pretty straightforward. We're just going to have some job templates that the first one builds what we did last time. And then the second one builds the VPC here, which is a little bit simpler. So in this scenario, we're just bringing up a new instance and I'm just calling it server one, but really all we're doing is allowing connectivity from server one, through this private AWS infrastructure, from VPC to VPC across these two regions, and they should have connectivity to web one and web two. So if I do a curl from here, I should still see the web page on web one or web two. And then from the front end, I should still be able to hit the load balancer, and then it should round robin between web one and web two on this side. Another thing that we need to understand is we have internet connectivity here. We have private network connectivity here with a route table that points to um, you know this space on each side, right? So this is in both directions. But what we can't do here is we're unable to allow server one to have end-to-end connectivity or transit connectivity to this internet gateway. So server one is unable to go in and out the internet over here and vice versa. So that's just, by design in the way that this works with VPC peering. So you're unable to do that or route, across this to something else like a direct connect, those types of things. So it's really just meant, again, VPC peering is pretty straightforward if you just want to connect VPCs together. When you want to get fancier than that and add, additional connectivity options, then the transit gateways, moving forward. So that's something that we'll address in a future session and take it to that next step. So that is, or this is rather, what the AWS side of the demo looks like. But with that in mind, the AAP will look a little bit different. So when I bring this up for the demo, what you'll see is that we're going to explore workflow. But in this workflow, each one of these boxes, and you can see that it has a JT, that stands for job template. Those are not the only types of what they call nodes that you can add into a workflow. Um, they're always represented with a box, but other options could be things like an approval node. So like if I want to do something and then have someone approve what that output is, I can create an approval step that kind of stops the workflow, or stops a portion of the workflow until it's approved or denied or canceled. And those approvals can also be accessed from the API or from collections from various other solutions like ServiceNow, or other tools that may front end what the automation is doing. So that way you can open up a ticket or send a notification to like a chat ops, and then somebody can ultimately approve it through the API, and then it would move forward. So that one's used a lot in more complex workflows. Another thing that you can have is you can update from a repository and sync. So that way, if something's changed, if you've written to the repository in a earlier step or an earlier node, then you can read in whatever those results are now, as the updated information later in your workflow. So a lot of times as you're changing things, you can do that from from a file perspective. What we're going to use in the workflow that's very interesting is we're going to set stats and create artifacts. So that way, if I'm learning very specific data objects in an earlier step, like in this case, we're bringing up the instances in this first step here, or this first node, and we'll glean from that like IDs, right? So those IDs for endpoints become available to the next job templates. Because as you set stats and create these artifacts, then they're available across the entire workflow until they're updated. So that allows us to maintain a state as we're working in a workflow. And we'll do that with various things, because a lot of these IDs, when we're creating something that's net new, then we're gleaning that from a playbook task, and then we can set a stat, and then that'll allow it to become an artifact. We can also set facts, right, and cache facts too in AAP. So when you can cache them so that, again, like those facts are available across these job templates or across playbooks, where normally when you're just running playbooks, you're kind of bound to that playbook, right? So if you learn something in a playbook, you can register whatever that output is and make that available. Or if you're gathering facts, that information is already available in memory, and then you can just call on it. That works great in a playbook, but here we're talking about sharing that data across playbooks or across these job templates in the workflow. So that way we have visibility into all those IDs, and that'll make a little more sense when we drill into it. I'll show you some examples of what I needed to do as I'm learning from here, and then I need to pass data here to create the VPC peer, and then ultimately we'll have everything running like I showed on the previous PowerPoint slide for the demo. These are just some references that, again, you'll have this available for you after the conclusion of this meetup. So kind of went through a lot of stuff, and now we're going to get into the live demo, but I just want to make sure there's no questions, if everyone's okay, before we start moving into the live demo, and I'll be changing screens and things like that. Okay, so it looks like everyone's okay at the moment. But again, if something comes up, just stop me because I won't be able to see the screen as I'm in the Ansible Automation platform controller. So this is the controller. This output here was the last thing that I ran, which was a job template that says AWS Network Cleanup. And what I was doing is I was removing configurations. So I ran this earlier to make sure that it works and crossing my fingers that it still works, right? Because who knows with these demos, something always seems to come up. But assuming that everything's fine, but I needed to clear it back out again. So I'm just running this job template that's just, pulling in information, removing stuff, deleting route tables and the like, right? So with this cleaned out, at this moment in time, I do not have any peering, which is a big portion of this demo, and I also do not have a load balancer or any linkages to the subnets. I do have to maintain the subnets that I created because I didn't destroy the actual instances because that takes too long. I don't want to build, VMs from scratch and install web servers and all that kind of stuff, which we could do, but I just want to kind of avoid that part of it. So I have to leave some of the constructs there that have dependencies, right? So it won't allow me to remove like the VPC, right? Because we have some instances already residing within the VPC. So because this is idempotent, when there's something there, it'll just leave it alone. But we'll be able to glean again like those IDs and other data points that we need. So the template that we want to look at is a workflow. So before we did this one, this networking demo one, it was just a job template. Now what we're going to do is an actual workflow. So it's this AWS networking workflow. And all this stuff is in the repo that I had shown you earlier, that link for. So if I bring this up, this is the same thing that we saw on the slide. You can connect in here and see some of the settings and things like that. Another thing that I would be remiss if I didn't point out is I could have other conditions like failed conditions where I could do like rollbacks and things. But for this one, I'm just moving forward. If anything were to fail, it just stops in its tracks. But what you could do is like rollbacks too. So I could have like a failed condition and when it fails and do a rollback or a notification or something like that as well. The blues equate to always. So when you start this, it always goes to this first job template. If I want to introduce parallelism, I can run multiple things in parallel that have no dependency. So they just kind of run on their own. And you can do that as well. Or I could have an always step that's in the middle of a workflow just because it's something that I need to do every time. So we could certainly use some of these other options, but this is, again, it's just meant to be straightforward, kind of a starter workflow, if you will. So to start it, I click the rocket here, right? And once I do that, it's going to spin up. This first one takes a couple minutes. So actually, while I'm talking, I might as well do that. So the instances, even though we're not building them from scratch, they still take a minute or so for them to turn on. So that's actually what's happening in this first job template. So to see that, I can click in the box and go to output, and then we'll see this happen. Again, it's not going to be too exciting because it's just bringing up the instances. So let me refresh this because sometimes my browser doesn't show everything in real time. And also some of it's just waiting, for this part to happen as well. So while that's doing that, I might as well bring you over here to this Git repo. And this is the one that I referred to earlier. So this is the cleanup, right? So this one's kind of messy. It's just a bunch of tasks to remove things. So I won't spend too much time there. The one that we're doing, or what we did last week, was this one. So this was demo one. I won't spend too much time here too because we walked through this in detail in the previous video. But one thing that's important here is the load balancer. So this is this will spin up, for the first time, and we need this because we need to glean what our domain name is, so that we can, ensure that those two web servers are running. So that's this last bit here, right? So we'll see that on the screen. The one that's new that didn't exist in the previous session was this demo 2. So this is the second site, and it's in US West 2. And it's in this first availability zone. You usually have at least 2 of them that you can choose from, or you can just allow it to pick for you. So with this one, what we're doing is we have to do a lot of the same things, but minus the load balancer, because we're not running a web server. This is just a server, just some app server, whatever, just for the purposes of the demo. So one of the things that I need here is this ID. So I just included this as a variable, and I've already built it previously, so I already know what this ID is. But a lot of the other IDs I did not know. So that's why we've variabilized a lot of these things, and I'm registering them. So we're calling in some variables, and then we're registering the output, because then I can use those for subsequent tasks. And I also have this thing that I mentioned earlier called set stats. So what I want to do here is I want to glean what that VPC ID is, because I need it later for my peer relationship. So once I do this, it's available again across that entire workflow. So it creates a state, and when I cache facts and things like that, like it's either in memory or I can actually store it on the storage of the controller if you check that box in your job template. So that one, it stays there until you override it. So when you run it again and the variables change, then it would overwrite that information that's stored on the controller. And then it's available as part of like the download artifact, information that you have on the controller. So here we're creating subnets, and a lot of the things that I'm building, again, you'll just keep seeing here that we have set stats. In the first demo, I didn't need to do that because we were within a job template like that bound us to a single playbook. Now we're exploring, multiple playbooks across these multiple job templates in this workflow. So I'm doing this as, one of the methods that I have available to share that data. So we move down, and a lot of, again, it's the same as the other one, the security group and things like that. So very similar to the first one, minus the load balancer. So let me go back to here and see what's going on. So at this point, the instances should be up, right? So I can go back to jobs and just see where we are from a workflow perspective. Actually, the whole thing finished. So that's good. So I can click on these and show you the output. So I'll do, so we went through this part and these two from a playbook perspective. I'll walk through the output, and then we'll walk through the playbook and the output of the VPC the VPC peer portion. And then I want to show you that hopefully all this stuff worked. So we'll actually go into the instances and, ensure that we have network connectivity. So this is the one that we did last time. So I'll click on this one, the second site, right? So it says demo 2. So when you look at the details, you can see that this job template points to this playbook. And the reason that it has access to it, or is aware of that path, is because in a job, or I'm sorry, in a project, we make available the GitLab repository that I'm using. So this is the playbook. The actual project is this AWS Networking. And when I click in there, you can see that this is the Git repository that it's pulling all the playbooks from. So if I go back to my job templates, and we were in 2, right, then this is the same information. And when I click on jobs, and then this is the last one that we ran, I click in there, and then this is the output. So, so the first part of this here, this is just gathering facts. So it just pulls in just information, like generic information from like a instance perspective. This one here, create new VPC, then this one is green because it already existed. I mentioned earlier that I couldn't remove that wholesale. So it's already there. So because it's idempotent, then when Ansible sees this, it goes ahead and it doesn't change anything, but it does read in all the current information. So when I click in here into the JSON, then you see that there's a lot of information in here. And then some of the things that are interesting and needed for like future dependencies are, what's populated. So we can get, all that output out of running it again, even though we didn't change anything. But it's useful in that regard, because if something were changed, then we would have that update as well. So here is the artifact that we created from it. And all we cared about was this peer VPC ID. So this is for the second region, the new region that we haven't touched yet. We need its VPC ID. So we were able to extrapolate that out of the previous task. And then it's made available, for moving forward, we'll have that data. And I'll show you what that looks like as well, where the artifacts go and where you can find them in before you run your job templates or when you click on them from a workflow. So here's some subnet IDs had to stay, the internet gateway, all this stuff had to stay because we left those VMs in there. But here's some of the things that I was able to delete. So this link from that new subnet to the internet gateway and the basic route table that we needed is something that we built that's new. So again, we have all these IDs, right? So all this information is available, like the route table ID and the subnet IDs. So all of these things are needed as we move forward. And you can see that in this route table here, we created this 10.20. So the 10.10 is a local address that's in the first site, the one that we created last week or whenever last month rather, and the 10.20 is a part of the new region in VPC. So we have an entry for that because before all we needed was our default gateway, and then now we have a new entry that we need because we're going to have to go across that VPC peer. So as we move down, we see these basic output from that task, and then the security group needed to be modified as well. So this first go around, all I really have is, and this one is just port 22, right? So we'll add to that in the next job template. So this is just what I needed, for right now at this portion of the workflow. So we created these things, and this allows for basic connectivity. So basically, at this point for server one, all you can really do is just SSH into server one. That's all the security group allows for. But we're going to update it to allow the connectivity for the VPC peer and things like that as well. So so that one, if I go back to jobs, so 1 and 2, and then here's the VPC peer. All right, so this one is create the intra-region VPC peering connection. So we do this, and let me show you the playbook for that. So here's the playbook. So for variables, all I have is I need to delineate what region we're talking about. So East 2 is the one with the load balancer, and West 2 is the one with just the server 1 that we've created this time. So the first part of it is in region 1, and with its VPC ID, we want to connect to the second VPC. So that's why I had to create that variable earlier in setstat, so that we would have the VPC ID that we can use, because what happens is you have to request from one VPC to the other. So this is the source and this is the destination. And then this is where the peer region is region 2, which is the US West 2. And what we want to do is, make the request, and then we want to register, all of that output. Now it doesn't come up like immediately. So what I'm doing here is I want to see and confirm the acceptance of the VPC peering. So the state is for accepting it, right? So this is built in because normally you're doing this from like a portal and you accept it. Here we're automating that, so the state becomes accept, and we're going to register that result. But I put some retries in here because sometimes it'll fail if this runs too quick. So I didn't want to do like a pause for like a set time. So usually by 3 retries, it's always finished. So I could add more if I needed to. So it's a little bit easier for me to tweak, just add, some additional retries. And then it'll go until it sees the result has not failed. So if it sees it the first time around, it'll stop. So it doesn't just waste time, retrying over and over again. And then once we have that acceptance, we also have to update our security groups. So you can see that on the front end to the server itself, I was only allowing 22. The ones we built the previous time, we were allowing port 80 because the load balancer was connecting with port 80 to each one of those web servers. So what we want to do is we want to be able to get from server 1 to either one of those web servers on port 80. So I opened up 22 so we can, like, if we wanted to go from like server to server, or port 80 so that we can do like a curl from server 1 to web server 1 and 2 across the VPC peer, and it should work. So the same thing, like we're doing this on both of these, right? So this is region 1, and then we're doing this in region 2. So that way, it works bidirectionally. And then here, what I had to do is I'm adding those entries for the VPC peer route table. So you'll see that when we look at the VPC peer in the portal, we'll see this route table. And so it'll have like a new entry that points to the peering ID. So it doesn't go to the internet gateway, it goes to the peering ID on both sides. So without that, even though we've connected together and approved like security groups, we wouldn't have a route. So we would have no traffic between those two. So we're just updating our route tables. So that's the playbook. And as we go back into here, so this was the first part where we're making the connection. All right, so as we do that, it just shows, what regions are being connected, and we're initiating the request, right? So this is the request. This is the ID that we need to pick up on, so we can create those entries in our route table for this. Right, so that happens, and then here's the approval. So it's just, allowing for that peer. And then because that passed, then we can go ahead and, update our security groups. So it's just, like we showed, port 80 and port 22. So not too extremely exciting, this part. All right, so here's where we update routing tables. All right, so this is, very necessary. So we needed to know like the routing table that we did earlier. So we have these IDs because we set stats, and then we're adjusting those route tables. See how like now it's using the peering connection to reach this network. So this is the local network, and then to reach the remote VPC, then it's this 10.20 space. So we're not pointing to the internet gateway, we're just pointing to that VPC peer for that to work. So that's all the pertinent output. Now here's some other things that I mentioned, like in how to do this. So in the how, if I go back here to the workflow, so we'll go to the workflow, and we can see like if I connect to the US East one, we have these artifacts. So this is where they go. So it's kind of like extra variables, but like these are the ones that we're learning as we go through. So we're populating these here as artifacts. So these are things that we didn't know. We didn't know like the VPC ID. We didn't know the subnet IDs or the internet gateway IDs. So this is information that we needed in order to run this particular playbook. So without that, then we would have had an error, that we would have, an undefined variable to run this one. And then just like that in the other one, so 2 will be the same way. We get the details, right? So we've got, same type of information here, but this is what we need. So this peer VPC ID is the VPC ID for the second site. So you see, like, just depending on which one it is the variables that we're using. So so once we run these, right, then that last one needed some additional data. So that was this one, the VPC peer. So I'll go to details. Oops, what the heck's going on here? Sorry about that. So let me make this bigger so I'm not scrolling around. Yeah, so the last one needed like all that data, right? So we needed the first site's VPC ID, the second site VPC ID, that task where we actually point to the peer, right? So we need those too for that, and then we need all these subnet IDs so that we can point to the correct subnet, and then we would be able from that to update that subnet's route table, right? So we needed all this information to come in. So assuming that everything worked, right? So the first thing is let's go and see what our console is saying. So this is the VPC from Ohio, which is the US East B. So when I click in this VPC and we move down here, we can see that I have the two subnets. This one's not being used, so it doesn't connect to anything. But this one is, and this one is, because we have two availability zones and two subnets in that first VPC, right? So here's the route table, right? So the route table that we want to see is like, I think it'll show it from clicking here anyway, but the viewpoint that we want to see is the peering connections. So here we can see we have an active peer. And when I remove these, they go to delete it, and it's just like terminating an instance. It'll stay in there for a little while, and then it'll eventually go away. So when I click into here, and you can see that this is the peering connection, right? So here's an ID that we were using. And then when we go into route tables and click in here, and then sometimes this takes a second, or I need to refresh it. If I don't see it on this one, I'll look at the other one, and by the time we come back, here we go. Yeah, so you can see in this route table that this is the local one, right? That's already there. And then here's the internet gateway one for the default route. And then here's the new one for us to access 10.20, which is the other site, right? So that one's pointing to here. So we're good from that regard. And then if I go over to the other one, which is Oregon, your VPCs, this one here is the one we want. Here's the same thing. Here we don't have the two availability zones, just the one. So we just have the one routing table. So I could click there, or we'll do the same thing and go to the VPC peering. Remove that. Click in there. And then click in the route table. And what did I do? Yeah, here we go. And this is the same thing. We've got our internet gateways, and now we're the opposite, right? So to get to 10.10, we have to go across the VPC peer. So in terms of like seeing if this thing works, and hopefully this still works. So I go into this tab, and I didn't know that's not what I want to do. Let me bring up a tab, or just click in here, server one. Okay, so here's server one. And then I always forget the IPs for the other side. So we're on the 10.20 side, right? So we need to connect to those two web servers that are 10.10 something. So what I did is I put a file in here so I don't have to remember it. So if we just curl the or cat this, I can just copy and paste and keep things simple. Right. So we just connected the web one, then web two web server on port 80, right? Because our security group allows for port 80 across the VPC peer. And then just to make sure that we didn't break anything that we were able to do last time, if I go back to here into jobs, and what I want is that demo one, and to the output, and go to the bottom of the output. This is the address for the load balancer. So I'll just click in here and grab it, or Control C when it's this particular page, just pop up. Pop it in here. And actually, it's hard to see too, so make it a little bit bigger. So we connected to web server one, and then it should look here. Yeah, so we're load balancing between 1 and 2. So we didn't break the load balance or anything, so that's all good. And then we have the connectivity, across the VPC to connect directly to those servers between each other. So I think that's everything that I wanted to show. So let me go back to here. And I know that was a lot of moving parts. So let me pause here. Does anyone have any questions on any of that voodoo magic we just saw on Ansible? Has anybody question? Has anybody tried to do something similar to this, or using a different tool? Maybe just as a discussion point. Could you give me a thumbs up if any of this made sense, or if anyone's still awake? Cool, thanks. Just make sure there's still people that are actually watching. But again, if you're interested in any of this stuff, I'll have this available where you can go back to the link on the Meetup past events and have access to it. And or if you have any questions too, there's comments in there where you can ask about this type of stuff. But I hope this took us to like the next step. I may not do this topic the next meetup. I might switch it up to something else, and then the one after that, I'll come back and do the transit gateway stuff, which is a little bit more advanced with BGP and all that good stuff. So we'll readdress AWS probably in a couple sessions from now. But again, thanks for attending, and have a great rest of your week.